Here we can see the graph of y equals f of x, where f of x equals x cubed plus 12x squared minus x minus 100. Here we can see the roots. We can see the root where the curve cuts the x-axis, which is seen to be between 2 and 4. Here is the zoomed in graph of y equals f of x, and the root is shown to be right here, between 2 and 3. When x is 2, f of x is smaller than 0. When x is 3, f of x is bigger than 0. This is seen to be a change of sign from negative to positive. As we go down, we can see that the method works by looking at the change of sign. We put in the formula into Excel, and this is only entered once and copied across the row with the click and drag tool. So we put it in here, and then we use the cell above it to be dragged across, and this is made easier for us to find what f of x is when x is a certain number. When we put this into Excel, we put it between 2 and 3 as this is where we know that the root lies between. We can see that there's a change of sign from negative to positive between 2.6 and 2.7. So this change of sign shows that the root lies here. This graph also shows in a zoomed in graph between 2.6 and 2.7 so that we can further find out where the root actually is. So we can see that the root lies between 2.6 and 2.7, and the root is right here as it is between this. When 2.6 is entered into the function, the f of x is smaller than 0, and when 2.7 is entered, f of x is bigger than 0, so there is definitely a change of sign. The same method is used as before. We use Excel to find out where the change of sign actually is. Here we can see that it's between 2.64 and 2.65 as it changes from minus 0.60506 to plus 0.22962. So the root lies between 2.64 and 2.65 as there is a change of sign. The graph below shows y equals f of x, which is also zoomed in further so that we can see whether it really does lie between these intervals. It lies between 2.64 and 2.65 as there is a change of sign, and because it changes from negative here to positive here. Below we put in these x values into Excel and the formulas to find out where the change of sign is. To 3 decimal places, we can see it's between 2.647 and 2.648. To 4 decimal places, it's 2.6472 and 2.6473. And to 5 decimal places, it's 2.64725 and 2.64726. We know this because there is a change of sign from negative in all 3 cases to positive in all 3 cases. We take the midpoint of the final interval, which is this one, and this is done by adding both x values together and dividing it by 2. So doing this, we find that x equals 2.647255, and this is with a maximum error of plus or minus 0.000005. Sometimes the method doesn't always work, and this is usually when there is a repeated root. In this case, I'm going to find the root of the equation f of x equals 0, where f of x equals x cubed minus 0.734x squared minus 5.0661x plus 5.89317. We can see that the root lies in the interval 1 and 2, as there is a repeated root which touches the x-axis right here. This shows the curve of this equation. We also use the same method as above. We use Excel to find out where there is a change of sign. So we know that it lies between 1 and 2, so we place all the values between 1 and 2 into Excel and the formula in the cell below. We look at the f of x values and see no change of sign as all values are positive. However, from calculation, I know that the value actually lies between 1.5 and 1.6. However, Excel does not show this because there is a repeated root, so there will be no negative y value. I know that the root lies in the interval 1.5 and 1.6 by looking at this graph. I can see that their curve touches the x-axis here between 1.5 and 1.6. However, the y-coordinates do not become negative because of this repeated root, so there will be no change of sign as it will be positive here and also positive here.